we was looking at this heat equation with the Dirichlet condition here on the two ends, and we derive the answers uxt equal to this summation. And now let's do one example with that. Example, if we have a rod of length L equal to 40 centimeters, and we have two ends are embedded in ice. So on-way temperatures 0 degrees Celsius, and we have this rod is heated at the time 0, at T equal to 0. We have uniform temperature, saying every single point on the rod, this rod of length 40, 0 here, L here, 40, and they both at temperature 0, and initially at T equals 0, Ux, 0 is say 100 degrees Celsius. For now, I just denote by U0. And we want to solve the heat equation. Try to find Uxt. So find the formal Fourier series solution of the heat equation. Ut equal to K U double X. K is a thermal diffusivity. Unit is centimeter square per second. So for now, let's just work with K. If we want to apply to a particular example, let's say the rod is made of iron. So example, if the rod is made of iron, then K is 0.15. But I will just work with letters K. The problem we are given is Ut equal to K times Uxx. You have U at 0, x0 is 100, and 2n in ice. So n0, t, and nl, t are both always 0. Initially, we have U x, 0 equal to 100. This is the problem we need to solve. And we just apply the formula we derived before, this one. The solution of this problem, as in the formula we derived before, we have Ux, t is summation n from 1 to infinity, a coefficient Cn, times exponential minus k n square pi square over L square times t sine of n pi x divided by L. Because our question L is equal to 40, the length of the rod, I will plug that in here. Summation n from 1 infinity Cn e minus k times n square pi square 40 square times t sine n pi x over 40. This is un, and all we need to do now is to compute Cn. Cn is the Fourier coefficient of Fourier sine series of this one in the formula we had before. This is f of x, initial temperature profile of the rod, 2 over L, 0 to L, f of x sine n pi x over L dx. In this case, 2 over 40, 0 to 40, f of x equal to 100 sine n pi x over 40 dx. So I have 100, can move it out. 200 divided by 40, 0, 40 sine n pi x over 40 dx, which means 5 times cosine, actually minus cosine n pi x over 40 divided by n pi over 40 x from 0 to 40. So we have 5 multiply 40 over n pi minus sign in front, cosine n pi times 40 over 40 n pi minus cosine 0. Cosine n pi equal to 1 if n is even. So we can draw the unit circle. Cosine n pi is here or here. 1 if n is even, and minus 1 if it is odd. Minus 1 if n is odd. And with that, you have minus 200 n pi multiplies minus 1 power n minus 1. You can write it like this, or you can write it as two cases. N is even. If n is even, this is 1 minus 1, which is 0. If n is odd, you have minus 2 times minus 200, 400 divided by n pi. And we computed Cn. Now plug that in this formula. We have the solution ux, t. Ux, t equal to summation Cn. Just plug in Cn there. Cn, I use, for example, this formula. Then just put it there. We put Cn there, we have the solution of the Higgs equation. Or you can write that summation n from 1 to infinity. I can just put this minus inside. 200 over n pi. 1 minus minus 1 to the n. Multiply this. Or I can also write as summation now only for n odd. Then with that we have 400 over n pi multiply with on this. So depending on our preference, you can choose either of those three equations for the solution of the Higgs equation.